and then we'll jump into direct and inverse quiz and test for that later in January. Questions on any of those things? There are 3 delta maths in all of this. One is for the first part, and that is due on the 15th, so next Friday. And then the other 2 will be due before you guys go on winter break, so on the 20th. I will not see you on the 20th because of Felix Palooza. The schedule is changing, so no one is seeing first period that day. So Tuesday the 19th will be the last time I see you before the new year. Questions on any of it? This is the last, all of this is the last stuff that's going in this quarter. When we come back and finish all of this and start Unit 6, that will be for quarter 3. Any questions, concerns? All right, so look at your notes. As you may have seen in the course calendar, we're doing scatterplots, line adjusted, linear regression. It's all connected related. So I'm going to be showing you guys how to do this in the calculator as well as in Desmos, and you'll be able to pick whichever one of you would like to use on the activities. So let's talk about some vocab first. Scatterplots are used to determine whether or not the 2 variables are related. A trend is when a change in one variable affects the other variable. Trends can help us make sense of the world around us and help us make predictions. Try to guess this one. A blank trend occurs if one variable increases when the other variable increases. Positive. Some of this will be familiar to you, some of it will not. This trend is much like a line with a positive slope, so we can see that as our x's increase, our y's are also increasing. That makes a positive trend. And then for this one, a blank trend occurs if one variable decreases and the other variable increases. Negative. And we can see as the x's keep increasing, our y values are decreasing, or that could work the other way as well. This trend is much like a line with a negative slope. And then does anyone know this one? There is blank blank between the number of newspapers sold and the temperature in the following example.
No relation.
Close, no correlation. So that means the points you see, they're not moving positively or negatively. They just aren't really correlated with each other. Right, and then another term used to describe 2 sets of data that have a connection or relationship is a blank. Anyone know what that word would be? It's the same word in the next part. The blank between 2 sets of data can be positive or negative. It can be strong or weak. I'll give you a hint. It's in this table. So we talked about the positive and negatives. The strong and weak we'll talk more about when we do what we're actually going to do. Right, but this vocab is here so that you have it for later purposes. Right, go on to the next page. going to do these 6 and then kind of skip around. So would this be a positive, negative, or no correlation?
No correlation.
What about 2?
Negative.
3, positive. They're moving more in the positive direction. They're not just spaced out. Number 4,
Positive.
positive. Number 5,
Negative.
negative. And then number 6.
No correlation.
When we talk about strong and weak, the closer the points, when we go to make a line, if the majority of the points touch the line or the line crosses through most of the points, it will form a line that will look more like a line, and that will be a really strong. So I would say that these two, this one's more so than this one, is really strong. This one and this one, not so much. Those are weaker, not as strong. But we'll talk about specific numbers here in a bit. We're going to skip 7 because that's just really plotting points. Go on to the next page. We're going to skip 8 as well because it's really the same thing. You are welcome to do that in your own time. We're just going to talk about some of these. So we have to think about these data sets as having a positive, negative, or no correlation to each other. So do they both increase together? Does one increase as one decreases? Or do they have no relationship to each other? The number of hours a person has driven and the number of miles driven. Would that be positive, negative, or no correlation?
Positive.
Positive. Because the more hours you drive, the more miles you have driven. The number of siblings a student has and the grade they have in that class. No correlation. They have nothing to do with each other. The age of a car and the value of a car.
Yeah.
It is negative because cars depreciate. So, like, you get a car in 2023, the car value is really high, but in 5 years, it won't be the same as when you first purchased it. So it is negative. We're not going to do all of these. I just wanted to go through some. Let's look at 12. The number of years a person went to school and their income.
No.
So I could see a reason for both. Positive, why? Usually the more you're going to school, college, the higher level degree you get something, you get more money. But also sometimes that's not the case. But in general, we'll say this is in general, this is a positive correlation. The number of songs downloaded on your iPod, whatever, and the amount of memory available.
That is a negative.
Negative. Because the more songs you have, the less memory you have. Let's do one more. The age, sorry, I was reading 14, but looking at the amount of time spent on the computer instant messaging your friends and the number of computers in your house.
No correlation.
They don't have anything to do with it. If you ever take a stats math class, you'll talk about correlation, and you'll hear something, correlation doesn't equal causation, which means they could be positively or negatively correlated, but that doesn't mean one affects the other or causes the other. Questions on how positive, negative, no correlation works? Let's go on to the next page. This will be most of the stuff that you will be tested, quiz, the activity will be on. The other stuff is stuff the county needs you to know. Right? This one, we're not going to do both of these. But if I wanted to find the y value when x is -2, how would I find that? So not like intercepts, but if I wanted to find what is the y value when x is negative 2. How could I
supposed to know that?
say that again?
How are you supposed to know that?
What did you say, Melissa? Plot. We could plot it, sure. There's something we can do algebraically to figure it out. So if I wanted to, it's kind of like evaluating. If I said x equals negative 2, and I have this equation, what would I do with it?
Nothing. Wait, so the y-intercept is 0?
So we're not looking for the y-intercept, we're looking for the y value. So when we evaluate, what do we do?
So the first one's negative 4 and then 5. Right?
Okay, how do you find that? So we're not looking for the y-intercept, we're looking for the y.
The y.
No, but no, it's not negative 4.
Is it negative 5? Positive 5? Positive 4?
So let's figure out how to find that answer. I said x equals negative 2. I'm trying to find the y value. What could I do with that? So negative 2 in for x. And figure out your answer, which would be negative 6 minus 4. Negative 7. So then you would do the same thing for negative 1. Which would give us negative 7. And then same thing for 0. So I put 0 in. Negative 4. Do we see a pattern? What is that pattern?
Minus 3?
Are we subtracting 3
Yeah.
each time? So negative.
Oh no, adding 3.
We're adding 3 because of the slope. So then what would this one be?
Negative 1.
And when we put 2 in?
Positive 2.
Positive. So getting you back to the mindset of evaluating, because we're going to be doing a lot of that in this, as well as other things. So that part is part of it, but we'll talk about that part later. Right. Everyone reset your calculators, because that's what we'll do this next part on.
How do you reset it?
2nd plus 7 1 2. And then we're going to go through the steps that is listed on your notes. So if you get lost at any point in time, all of those are right there. But first, on these notes, we have to talk about which of these is the x, which is the y. So in this table, you are given data collected in hours for time spent studying for the test and the grade received. Not in this class, not in my classes in general, just in general. There was one on the floor, but I don't know where that one went. I don't have extra batteries. Grab another one. Okay, so for this table, time and hours and the grade, one of them is the independent, one is the dependent. The independent is usually your x, the dependent is your y. So if you're not sure, you could ask, would time and hours depend on the grade, or would the grade depend on time spent in hours? The grade would depend on the grade. So the grade would be our y, and the time would be our x.
How do you know that that's why and the other one is x?
Because the grade depends on the time.
Oh, okay. So y is dependent and x is independent?
So then in your calculator, you're going to follow the following steps. Go into stat by the arrows. So everyone should be doing this along with me.
Well, where is that? Oh,
Yeshaya, did you put this in your calculator? Kareem, did you put this in your calculator? Okay. And then you're going to go, it's already on the edit screen. In edit, hit enter or 1. And you're going to type the numbers you see from your table in here. You can either type in the number and hit enter, or you can type in the number and hit the down arrow. Doesn't matter. But fill out your L1 and L2. X is going L1, Y is going L2. All of these numbers are on your paper. Okay. The next thing on your paper, on your note says something about clearing lists and missing lists. That's like if you miss something or missing something. We're not going to cover that right now. And then we're going to go to step 2, which is go back to stat, to the button you were at. Scroll to the right to calc. And then we're looking for linear regression. There are 2 of them, but we want the one that looks more like our y equals mx plus b format, even though it's a instead of m. That's how the calculator is. So you can either just press number 4 or go down to number 4 and hit enter. And then you should see a screen that looks like this. Make sure this says L1, this says L2, there's nothing in the frequency list, and go down to store regression equation is what that stands for. And you're going to hit alpha, the green button, and then trace at the top near zoom and graph. This menu should pop up. It doesn't really matter which one. You can just hit enter 3 times.
Would you click after alpha?
Trace.
It's at the top.
Remember, all these steps are in your notes right in front of you as well.
Well, what did you click after that? After trade?
Enter 3 times.
Enter.
Enter 3 times.
Alright, so at the bottom of your notes, it has these same numbers. If you don't have these, you may have typed in the wrong numbers originally, so go back and double check those. Okay. I'm going to show you what this looks like in general. You do not need to do this part, so just watch. So don't do all of that. I was just showing you what this looks like in general. So each of these little squares are all of the points from your table. And this line is our line of best fit. It best fits this data. It doesn't fit all the points. It doesn't go through all the points, but it's closely related to all of the points. I can use this equation, this line, for any number in general. So if I want to find what would the grade be for someone that spent 0 hours or 2 hours or 4 hours, I could use that equation for that. So that's the purpose of what we're doing. Finding the line of best fit and then using it to make predictions. So now on the next page, it asks those questions. So we're going to type right in our line of best fit at the top. When you write in the line of best fit, you do not need to write all the decimals. That would take a while. But you do need to write at least 3 decimals, rounding the third, rounding the
Hundreds.
So like we have to remember all these steps.
yes. So y equals, from your calculator or from the previous page, 6.012 x plus 53.615, which would round to 6. So that would be our line of best fit. Then it wants us to predict the grade given for a student who studied for 0 hours. There are a couple different ways to do that. You could put 0 in for x, evaluate it like we were just doing before, figure out what that would be. Or I'm going to show you how to do it on the calculator. So if you wanted to try this on the calculator, this only works if you did the steps where you stored the regression equation. If you didn't do that, this part won't work. But from this, I'm just going to type in 0, and then STO above on, and X, and then hit enter. So do that part. 0, STO, and then X, and then enter. It won't look like anything happened, but we have to go back and grab our equation where we stored it. So go back and hit alpha trace. And then wherever you stored it, which is most likely number 1, hit 1 or enter, and then enter again. And what it did was took 0, put it into your equation, and evaluated it for you, solved it for you to get your final answer.
Wait, so why didn't we just put this one? The one that
Because that doesn't have all the decimals, so your answer wouldn't be correct.
So we have to write all the decimals?
No, we don't have to, but the calculator needs to. So your answer for that one would be 53 point, for your answers you can round to 2 decimals, so 53.62. If this wasn't looking for a grade, we would put some sort of label, but because it's looking for a grade, you can put percent if you want, or leave it. We're going to do the same thing for 6. What questions do we have so far?
Can we just like put that in calculator and just instead of x put like 6 or something? Would that work?
Put what in the calculator?
Like instead of that x, we put just 6.
Into the equation.
Oh no, we like just write like we don't
Like
have,
what we just did.
yeah.
Yeah, that's what we're doing. So just like the 0, we're going to store 6 for x, 6 STO x. And then grab your equation from your y1. Alpha trace, enter twice. And if you were doing the work on the calculator, you would put 0 or whatever your number is, arrow or store for x, did it in the calculator. That would be your work. You wouldn't have to do anything else. But our answer, 89.69. If you were to put 6 into this and not into the one with all the decimals, you would not get the exact same answer. So be very careful that you're not doing that. 0 would work, any other number would not. Now for the last question, how many hours do we need to study to get greater than 100%? So all the other ones we were given our x values, had to find our y values. Now it's been flipped. Now we're given our y value and have to find x. So you could set it up as an equation. and solve for x, that would work. If you wanted to do it that way, that would always work. If solving for an x value. Or you could do it in the calculator. And I'm going to show you how to do it that way. Whether you do it in the calculator or by hand is up to you. So because we have this y value is greater than 100, again, this part only works if you did the store regression equation. Go into the table, second graph, and you'll see a list of values. We want our y value to be greater than 100. At 8, we see it is that, but what if we wanted to find the specific, where exactly does it go over 100? We're going to change this a bit.
7.5.
We're going to change the calculator. So go into a second window, and we're going to change the start to be 7. And this is how much it's counting by. We're going to change that to be 0.5. And then we're going to go back to the table, second graph. So now I see that still at 8 it goes over 100, but somewhere between 7.5 and 8 is where I'm looking for. So I'm going to do it once more. Second window, I'm going to change this now to 7.5 and change this to 0.1. And then go back to the table, second graph. Now I see at 7.8 it went over 100. So that is a very specific. You could keep going and do hundreds, thousands, but 7.8 is fine. Because this one was looking for number of hours, you need that label hours. Now I'm going to show you how to do this in Desmos, and you'll be able to choose whether you want to use the calculator or Desmos. Desmos has less steps. So open up your iPads. If there's anything in there already, clear it out. Get rid of everything that's already in there. X it all out. Okay. Then in the corner, hit the plus. And you're going to add a table. Plus table. And we're going to put in the table that's on your notes. It's a little blurry, so if you need to read mine or look at mine, that's fine. I'm going to type it because it's a little bit easier that way. So 6 and 260, 13 and 320.
What was the first thing you hit?
Plus table. 21 and 420. 31 and 560. 28 and 560. 20 and 440. And 25 and 500. So make sure you have those numbers in your table. Yes. Once you have all of your numbers in your table, in the next open line, you're going to type in something that looks like y equals mx plus b, but is a little different. Because our table has x1, y1, we need to include that in our equation. So we're going to type in y, and then 1. It's going to do this by itself. Then in your keyboard, you need this squiggly line. It's called a tilde. And then mx1 plus b. You just type it. So type in y and then 1, the tilde, m, x, and then 1, and then plus b. The squiggly line is in your keyboard. So you should see numbers that look like this. The residuals E1 plot, don't worry about that part, we don't need that. That's more in stats. The R2 is your correlation coefficient. That tells you how strong or how weak this data is. You may not be able to see any of your data, but if you hit this plus at the bottom of your table, you should. So,
plus?
This plus at the bottom of your table. So our R squared is a 0.97. The closer this number is to 1 or -1, the stronger it is. So this goes through almost every point on this data. It's pretty strong. This would be your line of best fit using this M and this B. You would write that down.
How do you write that down? Like, is it mx?
Y equals mx plus b. I'm debating if we have time to do number 1 on the next page or not. Do we want to start number 1 or do we want to wait till tomorrow?
Wait till tomorrow.
So we'll do that, and then we'll do a few problems tomorrow, and then you'll have time to just practice using either the calculator or Desmos, however you can. If you would like to keep practicing now, you are welcome to do that. If you have questions about the calculator or Desmos, you can come around. But if you have no questions, aren't practicing, you can put it away.
Can we take